Hi. Okay, so it is our fifth part of our lecture. Lecture series, the calculus for full, the part 5, right? Okay, so just recalling our part 1 of our previous lectures and past lectures of our series, part 1. Okay, so there was, I had actually introduced two symbols, right? One. Okay, just our topic is a calculus for full, right? So the first part, I had introduced two symbols. One is D, and small d, it means actually a little bit of, right? A little bit of. And another one was with a large S, right? And it means sum of. Okay. So one is D, a little bit of, and another one is the sum of. Okay. So that the name suggests, if there is a very big line with a length x, so the dx is actually little bit of x. That means if there is a very big straight line with length x and if you cut it piece by piece, right? If you cut it this straight line piece by piece, one of these pieces, very small piece actually, giving a little bit of. But little bit piece, okay. If you cut it a very little piece, one of these pieces is called dx, right? Dx. And d means actually a little bit of. That means if this is an x actually, so dx is actually a fraction of this thing. A fraction of x, right? A fraction of x. So d means a little bit of or a fraction of something like that. Right. Okay. Okay. And then these symbols, it means the sum of a little bit of x. And the sum of means just addition, right? Okay. Just the name suggests sum of addition. That means if we have small pieces here, dx, another dx, and if you add this dx one by one day you will get full length of this line, right? That means you will get x. Okay, so actually the d means a fraction of something, and then the t is an operator, the dx is an operation, right? So d is an operator, and what is this operator actually? This operates on x and it actually breaks the x, right? It breaks the x into very small pieces. So d is the operator which breaks a very large scale x, very large length x into very small pieces. Right. So it's breaking down. It is breaking down. Giving something breaking down. And this is actually this symbol, sum of, it means if you add this small part one by one, we will get the full length of this straight line. That means it means actually an addition. It is actually addition. Addition. So there is a two operator. It is an operator. It is an operator. It means breaking down. It breaks a very large thing into a very small pieces. and this means the operator will add this very small pieces one by one and we will get the full length of it. Okay, it is the addition operator and it is the breaking operator. Right, the addition operator is the breaking operator. This is the breaking operator and this means the addition operator. Okay. So of course this is actually a reverse process. No? Is D actually the act of D means something very large thing and breaks down to very small parts, and this symbol means from these very small parts we will add these very small parts one by one to get the whole thing. Just a reverse operator. These two operators just the reverse one. It does the reverse one. Right. Okay. Just the reverse one. Actually, number one finding is here. So D and the largest the reverse operator are the reverse operator. Right? This is actually the reverse operator. One operator breaking down the system and one operator actually unite the whole system. Right? One operator is just breaking down the system and one operator unite the whole thing. Just in reverse case. Right? Okay. So the reverse operator is two. That means, and one thing, right? One thing. If it is a dx and it will operate with this sum of symbols, we get x, right? The whole thing. Similarly, if you have it is a dl, it will get l. If it is dt, we will get t. Right? So similarly, if it is dx squared, we will get x squared, and the sum of little bit of x squared, we will get x squared. If it is d over x cubed, sum of little bit of x cubed, obviously we will get x cubed. Say it is d over x power n. Sum of little bit of x power n, and if you add this x power n one by one, obviously you get the full x power n. Right. So the same thing with some constant into x power n, then obviously you get x power n. Just a similar thing. Okay. So it is just what? So same. Sum of the bit of x means x, sum of the bit of l means l, sum of the bit of t is t, sum of the bit of x squared means x squared, sum of the bit of x cubed means x cubed, and so on. Okay. Now, we actually are the first formula of derivative dx. What was that? D dx over x power n is actually n x power n minus 1. Right? Okay. So, if you just cross multiply here, the down here dx is denominator, and if you cross multiply here, what will you get? So d over x power n and in x power n minus 1. This is a very simple. Okay. And from here, if you want to calculate what is x power n, what is x power n. So what will you do? Actually, is the d of x power n here, and from this thing you should calculate what is the value of x power n. So simply the sum of little bit of x power n. Obviously there is operation sum of obviously is operation a power n cube, and then is the x power n obviously all of you know. Sum of bit of x power n equals to x power n. So the x power n converted to this is the n x power n minus 1 dx. Right? Okay. Now just let so from here I will go this. Okay. Now just let n equals to t plus 1. So just let n equals to e power t plus 1. Then what will be the equation? X power t plus 1 equals to instead of n we will write t plus 1. Then x n plus n equals t plus 1 minus 1 is x. Right? And it is actually a t plus 1 x power t dx and x power t plus 1. Right? Okay. Okay. Then if you divide, just divide with t plus 1, then what will you get? Is it t plus 1 over t plus 1, and then here 1 by t plus 1, sum of t plus 1 here, x power t plus this, and obviously t plus 1 t plus 1 cancel out. We will get x power t dx. Here x t plus 1 over t plus 1. This is actually our first formula of the sum of, right? This is the sum of, and one can say it's an integral of just anything, the sum of or maybe integral of, you can say anything, right? Okay, so what I will do here, I will read now. Okay, just see from our first thing I will introduce here, just introduce two operators, d and the sum of this reverse operator. Okay. Now I will do this reverse operator. That means if d dx of x power n equals to x n minus 1 into x, then our reverse operator says that if it is just cross multiply with the dx, so d of x n x power n minus 1, sorry, and dx. And the reverse operation says that if d of x power n is this thing, then obviously the integral of the sum of this thing will be this. Just reverse operation, right? I mean, okay, so if m operates on 2x, if it is somehow k, okay, if m operates on 2x and the value of this thing, just let the value of this thing will be somehow 3, then if you use And reverse operator of n, m like n. So n of 3 will goes to 2x, right? So m and n is the reverse operation. M and n are just the reverse operator. Okay, just the reverse operator. I mean, if m act on 2x goes to 3, then if you use n over 3, it will goes to 2x, right? Just a reverse operation. Just a reverse operation. Okay. M is an operator and n is another operator, and if it is these two are reverse operator, then if m takes 2x and just give 3, then if n operates on 3, we give 2x, right? Just a reverse operator. So obviously, if the d over x to the power 10 goes to this thing, if I will operate with sum of, the whole thing becomes x power 10, right? Because these two, d and sum of, are reverse operator, right? So obviously here, the c, if you operate in this thing, if you operate integral or sum of over this thing, you will get x power n. That means if d operates on x power n, will give these values, then the integral or sum of this thing will give x power n. Just in reverse operator, right? It is a reverse operator. Okay. So now there I will proceed with the further formula. If x power t dx, integral over x power t dx, you will get x power t plus 1 by t plus 1. Okay. So then number 1 formula of the sum of s, and here is a dummy case, right? You can be anything. It may be 2, 3, 4, 5, any constant number. So you can write it instead of t, you can write it n. Ultimately, with x power n dx here, so you will get x power n plus 1 by n plus 1. Right? Plus instead of t, you will use n. Okay. So these are formula. The first formula of sum of the integral, right? Okay. And of course, as usual, the c here. If d operates on xn, this is value. Then sum of operates on these values will be x power n. Just for a reverse case, right? Just for reverse. Okay. Okay, so then is number 1 formula. Then if okay, so as from our previous classes, I mean either the part 1 or the part 2, there was I actually introduced as number 2 formula of d over dx. Hopefully it was ax power n, as in a constant into x power n, which will just it goes to some a into n x power n minus 1. And just cross multiply with ax power n equals to a n x power n minus 1 dx. Okay. So actually d operates on this thing, you get this. So if I use here reverse operator, I mean if I use here sum of n x power n minus 1 dx. So obviously here is dAx power n. So then the d has sum of a little bit of something. So ultimately we get ax power n equals to ax power n minus 1 dx. Right? Just in reverse. This is the act, the reverse operator, and we will get this. Right? So d operates on this thing and we will get this thing. And if somehow operates on this thing, we will back to the campus. Right? Just back to the campus. Ax power n. Right? So now I will introduce here from that equation the second new formula of the integrals and the sum of. Right? So okay. So just it is if ax power a into n x power n minus 1 dx ax power n, and just the same procedure I will follow in the previous calculation. If n, just let n instead of t plus 1. So let n equals to t plus 1. Then n means t plus 1. X will go here, instead of n you will write t plus 1 and minus 1 cancel out. We will get dx here and the ax power t plus 1. Right? Okay. So ultimately there is a t a into t plus 1 x power t dx will be ax power t plus 1, and just divides with t plus 1. What do you get? Let's cancel out this t plus 1 cancels out, and then we get left over a x power t dt. Then a x power t plus 1 by t plus 1. Okay? So you divides it with t plus 1, then here t plus 1 in the numerator and the t plus 1 in the denominator cancel out, and here is the vector of situation. Okay. Just see what is this actually. Here a is actually a constant, right? The constant remains constant. The constant doesn't hamper your calculations, right? The constant doesn't hamper your calculations. But instead of x power t, there is a formula x power n equals x power n plus 1 by n plus 1, plus x power t equals 2 x power t plus 1 by t plus 1 is a constant. Actually, the constant doesn't hamper your calculations, right? Okay. So it is our second calculation, second formula. So if either t is a dummy index, so instead of t you can write x power n dx, sorry, dx, right? So you get a here is a constant. Constant remains constant, it doesn't hamper calculation, and x power n becomes x n plus 1 by n plus 1. Right? So it is our number 2 formula. Right? Okay, so I raise it. It is our second formula. If ax power n dx, then the constant remains constant, and for x power n dx, sum of it goes x power n plus 1 by n plus 1. Right? Okay. Okay. So now, and then obviously. For our the last formula, third formula of dy over dx was probably if y is ax power m plus bx power m, then dy dx goes to a m x power n minus 1 plus b m x power n minus 1. Okay, and dy dx means simply it is actually d dx over y is here ax power n plus b x power m, right? And obviously, if you obviously if you just cross multiply it here, a m x power n minus 1 plus b m x power n minus 1 dx, that is d x power n plus b x power m. Okay, so obviously d operates a power a into x power n plus b into x power n, and you got this thing. So obviously if this reverse operator operates on this thing, we will get this, right? Ax power n plus bx power n. Okay, if I introduce here the symbol that sum of, so you get here the sum of d over this thing, we will get ax power n plus bx power m, and that is a m x power n minus 1 plus b m x power n minus 1 dx. And you just multiply it, same thing, right? A into b plus c equals to ab plus ac, right? This is actually your commutative rule. So it is a into b plus c means ab into ac. So for this thing you write somehow separates it a m x power n minus 1 dx plus sum of into b m x power n minus 1 dx. Okay, so I will so it's nothing here. It will introduce instead of n. Okay, so let me write down. Here. Okay. So yeah. Okay. So ultimately here is ax power n plus bx power n equals to sum of a n x power n minus 1 dx plus b m x power m minus 1 dx, right? Okay, and then accordingly just follows the previous pathway. If n equals t plus 1 and m equals some p plus 1, then what will happen? It's very simple thing. Instead of n, just write down t plus 1 here. And instead of just put it the same thing, right? Just put it the same thing. Just simply. And then bx power m plus t plus 1. T plus 1. So here is a t plus 1 x power t dx plus b t plus 1 x power t dx. Right? Okay, now you will just divide this equation with t plus 1, just divides with t plus 1, you get ax power t plus 1 by t plus 1 plus bx power t plus 1 by t plus 1, and here ax power t dx plus bx power t dx. And it's very simple. It doesn't hamper, it remains constant. X power t will get here. X power n becomes x to the power n plus 1 by n plus 1. So x power t will become x power t plus 1 by t plus 1. It's b remains constant here. There's a plus sign here, there's a plus sign, and this x power t equals to x power t plus 1 by t plus 1. Right. And if you introduce here t, another t, just if the t is n, just write the n is the m, just dummy index now. So you can write down. It's the n is the m. So instead of t here, you just write n, and there is m. The same thing actually. The dummy index you can change. Okay. So ultimately, number third. If ax power n dx plus b is the same thing, right? It's just the same thing. It's not a new model actually. It's the same thing. It's actually ax power n plus 1 by n plus 1 plus b x power n plus 1 by n plus 1. Right? Okay. So now in the number third is just nothing actually. So now it's just redundance of number 2. Right. Okay. Now what will happen if I will introduce some constant into dx? What will happen? What will happen? The sum of some constant into dx. What will happen? Yes, you can make this simple form. A is just 1. You can write here 1. A into 1 is obviously 1, right? So a into 1 into dx. And 1 means x power 0, right? Because something equal to the power 0 is actually 1. Okay. So you can write it. If there is a into dx, so just write it a into 1 into dx, the same thing. And instead of 1, you can write x power 0, the same thing. And this is our formula number 2. A remains constant, and if just here x power n, you will get x in power, x power n plus 1 by n plus 1. So there is just follow. There is a n, there is 0. Okay. Just press the value here. So x will goes instead of n just to 0. So 0 plus 1 by 0 plus 1. So a x to the power 0 plus 1 makes 1. So ultimately a into x, right? Yeah, so actually if it is in the sum of a into dx, so you get a into x, right? ax plus a into x, because the constant remains constant, and sum of dx, I mean sum of little bit of x, is actually x. Very simple. Okay. So I introduce here this 3 main formula of sum of, I mean the integral of, you can say integral of, okay, and then
Then tomorrow actually, our next classes, I will introduce the geometrical meaning of sum of, right? The geometrical meaning of this sum of, right? Okay, so today let's stop. Okay, okay.